Hi all, I'll be presenting on the project hosting and securing application on Azure and GCP platform. This project highlights the significance of including security control into the application development process. First of all, let me introduce myself, Sankaran, and we have three other members, Sai, Aashiq and Abraham. We have utilized three approaches in this project. First, we deployed two virtual machine instances on Azure, one as an application web server, another as an application database server. We also deployed a static web page on a serverless instance on GCP. This allowed us to enhance the availability, scalability on an hosted application in both the platforms. On our first approach involved hosting the application and database on two separate Azure VM instances. The web server was hosted on Apache Web Server and database was hosted on MySQL Server. The two VMs were connected via configuration VMnet virtual network. The VM holding the web server and application frontend was given an external public IP, whereas the database server was only be accessed through VMnet network, which is an internal network, or through an Azure console. The second approach involved hosting the application on Azure using CI/CD pipeline, continuous integration and continuous deployment. A CI/CD pipeline is a set of procedure for deploying software or application. Using this automation mechanism, we were able to ensure higher quality and secure code. This application to be hosted on the cloud was stored in GitHub repository. Using Azure Deployment Center, the GitHub repository was connected to Azure and the permission for secure deployment was set in GitHub repository. On our third and final approach, we hosted a serverless instance in GCP. We made use of a GCP E2 instance, which is a predefined deployment template. The instance was hosting a static web page. It was given a public-facing external IP to access web page. This was also configured to automate the deployment through CI/CD pipeline. Our project plan consists of 6 stages. First, we gathered all security requirements for the selected application, as well as selecting the appropriate cloud service provider. Second, we planned and designed the components required to host and run the application. Third, we secured the application code by implementing additional layer of security control and secured the application and its database within the cloud environment. Fourth, we planned and implemented the appropriate security controls and cloud security tools. Fifth, we tested the cloud security controls and mitigated any potential risk identified. Finally, any security risk or bug which was found in during testing phase were mitigated using various appropriate resolutions, and the cloud application environment went through another round of testing.
We have implemented following cloud security tools and controls. Identity and access management. It is a set of rules, procedures, and technologies designed to make managing digital identities easier. By default, access to these resources is initially restricted to the application owner, and permission for the rest of the project team is granted through the addition of rules specifying the necessary privileges. Anti-malware protection. It is a software needed for protection of application and cloud environments on the cloud. Both Azure and GCP have anti-malware solution for the cloud. By default, basic anti-malware settings are enabled. However, anti-malware monitoring needs to be enabled for monitoring of the resources to start. Event log monitoring. The process of recording and analyzing changes in the state of cloud environment, it is known as cloud event monitoring. Primary features of event log monitoring are setting policies, alerts, and data collection. To create a monitoring instance, a monitoring workspace for the resource group is added, where the monitoring service is then added to which monitor the application metrics and displays the event log. Virtual networking. A virtual networking in Azure and GCP is a logical construct that is constructed on top of real Azure network fabric. Each logical virtual network is separated from the rest of the cloud virtual networks. By default, basic rules like HTTP and HTTPS can be set during creating of VM. If additional rules needed to be set, like for services of the application running on a different port or to enable SSH or RTP. Firewall and DDoS protection. Cloud-based firewalls are network technologies that are software-based and are deployed in cloud to restrict or prevent unauthorized access to private network and resources. Both Azure and GCP provide a variety of firewall as a service solution based on the needs and requirements of instance hosted on the cloud. Infrastructure tools. The infrastructure of the hosted application in the cloud environment must be monitored for uptime and availability. Both cloud providers provide a comprehensive monitoring tool for gathering, evaluating, and responding to any infrastructure and network related metrics and events. This service feeds into the central event log analyzer for detailed analysis. Network monitoring. Both cloud service providers includes tools for monitoring, identifying faults, analyzing performance metrics, and activity logs for network resources within the cloud environment. This continuous assessment of resource levels, server response times, and speed forces potential vulnerabilities to future issues before they occur.
All the three approaches which is explained earlier uses the same testing cases. We are actively monitoring for security related issues using the built-in cloud monitoring tool Microsoft Defender. And we are also keeping an eye on the hosted application, but we have not discovered any security warnings thus far. In test case 1 for network testing, we used Nmap to see which ports were open and discovered that port 80 for HTTP and 22 for SSH were both open. In test case 2, we used Nikto tool to test the web server, and as a result, we see there is no issues that we could prominently found on cloud environment. In test case 3, we used Nessus, a vulnerability scanner and network security tool to look for vulnerabilities, and we found none. As a consequence, you can see that there were no vulnerabilities considered to be critical, and all we obtained was information about the site with no security concerns revealed during this test. During this SSL scan test, we found that the approach 2 deployment looks secured utilizing the SSL certificate. We used an online pentest tool to scan the deployments for vulnerabilities, which gave us these CV scores and ratings. As you can observe in the table, that this tool also gave us the recommended mitigations to be used for its respective CVs in the table.
Now we were able to deploy the application on this cloud service providers using the student subscription provided. The student subscription has limited access or trial-based access to certain tools and certain security controls. For example, the SSL certificate has to be bought at an additional cost. The SSL certificate would have made the application more secure. This is just one example. Now, when an application is deployed on the cloud for real world and we have full access to the cloud service provider, there are certain tools and certain security controls that we recommend has to be implemented for a similar application. So the first one is disaster recovery. Now, as an organization, it's important to have a business continuity and disaster recovery strategy that helps in protecting the organization and keeping its application and resources operational during an unforeseen outage like an attack or a disaster. Now, as part of the disaster recovery strategy, you need to have recovery instances in place of any resources or data you have hosted. So in the case of an outage or an attack, if the primary instance goes down, the backup instance can take over and the operations or the business of the organization continues to function. The second one is VM disk encryption. Now, it's very important to keep any data stored in an encrypted format. So so that you can maintain the confidentiality of the data. And in the case of it falls on the wrong hands, such as an attacker, they won't be able to access the actual data since it's encrypted. Now, the third one is a load balancer. Now, a load balancer helps in dividing the network traffic or load evenly among numerous servers or backend resources. So in the case of an application which needs to serve numerous or multiple users, the load balancer acts as a single point of contact and it distributes the incoming flows to multiple instances in the backend. The fourth one would be using an SSL certificate. Now, a SSL certificate or a digital certificate helps in encrypting the communication that happens between an end user's browser instance to the web application. And like mentioned before, that any data that's stored or that's in transit, it's important to have it encrypted so it's not easily accessible to an attacker. Now, the fifth solution is an Azure Active Directory or Azure AD, and this solution assists in safeguarding access to applications and resources throughout the corporate data center and the cloud. So this is one solution that helps in monitoring and controlling the user's access to these apps and resources. Not only their access, but also the actions that they can perform on these applications and resources. Now, the sixth recommendation would be using an application performance monitoring solution. An application performance monitoring monitors how the application is performing based on performance metrics, and it enables us to assure that the instances on the cloud work at their peak efficiency. Now, the seventh recommendation would be using a key vault. A key vault helps in storing sensitive data such as password, API keys, certificates, and cryptographic keys in an encrypted format. So this service assists in controlling that access as well to those sensitive data. Overall, this was a very good learning experience for us. We deployed an application on Azure and GCP. We followed industry best practices for deploying an application on the cloud. We ensured that the baseline configurations were followed. However, due to the limited access we had on the service, we were not able to implement some of the recommended security controls on the cloud. From our personal experience, we felt that deploying an application on GCP seemed easier compared to deploying an application on Azure. And some of the tools in GCP were priced higher than in Azure. And overall, this was a very good learning experience and hands-on experience to get on deploying an application on cloud.